Hello dear students, Assalamu alaikum. In this video I'm going to solve some questions related to Cambridge A-level mechanics, problems related to momentum, work energy power, or there will be some questions where both momentum and work energy power problems will be incorporated. I hope this video will help you. Thank you. So let's hello dear students. So this is a question related to work energy power and it's taken from specimen paper. Specimen paper 2020, the specimen paper which is assigned for the syllabus of Cambridge AS Mechanics 2023 to 25. So this is the question of (2020) specimen paper. Question number 2. Paper 4. So let's go through the question first. A constant resistance of magnitude 1350 Newton acts on a car of mass 1200 kg. The car is moving along a straight level road at a constant speed of 32 meters per second. Find in kilowatt the rate at which the engine of the car is working. Now, always go through the question properly because there are some key informations which you need to use for solving the question, like the car is moving along a straight level road at a constant speed. So when the car is moving at a constant speed, so definitely the resultant force on the car will be 0. Okay, and as it is moving at a constant speed, if we want to find out the power, we can use the formula power equals to force into velocity, because the velocity is not changing. So that means the driving force will remain constant, and also the power provided by the engine will also remain constant. Now, one interesting thing is driving force is not given, but resistive force is given. So when something is moving at a constant speed, if it's moving at a constant speed, so that means the resultant force has to be 0, right? So the forward force is the driving force and the backward force is the resistive force. These two forces have to be equal. Otherwise, it won't be able to move at a constant speed, right? So in case of this formula, power equals to force into velocity, that force is actually driving force. This force is actually driving force. Now, as the driving force and the resistive force is equal, so we can write down P equals to the value of the driving force is equal to resistive force 1350 and the corresponding velocity is 32. So you will get the power from here 135. 43,200 watt. But we need to find out the answer in kilowatt. So the power will be, if you divide it by 1000, because if you want to convert it into kilowatt, you need to divide it by 1000. So 43.2 kilowatt. So that will be the rate at which the engine of the car is working. So always remember, the rate at which the engine of the car is working means they're asking about the power of the car. Okay, fine. So let's move on to question B. The car travels at a constant speed down a hill inclined at an angle of theta degree to the horizontal, where sine theta is 1 divided by 20, with the engine working at a rate of 31.5 kilowatt. Find the speed of the car. Now look at here, a constant resistance of magnitude 1350 Newton acts on a car of mass 1200 kg. So that means in question A and B, two different conditions. In A, the car was moving at a straight road, and what was the resistive force? Like friction and air resistance, that was 1350 Newton. In case of B, the resistive force will also be 1350. Two different conditions, because in B, the car was not moving in a straight line, horizontal line, rather it was moving down a hill which was inclined at some angle. Okay, but as this information is given in the initial stem of the question, so in both cases you need to consider the resistive force as 1350 Newton. For B, your first step should be to draw a proper diagram and also distribute the forces properly. Then it will be easier for you to understand in which way you should proceed to solve the question. So the car was moving down a hill. The weight of the car will always act in downward direction, that's mg. There will be a component of weight along the slope or inclined surface, that's always mg sine theta. Mg sine theta, and the resistive force is 1350 Newton, and resistive force always acts in the direction opposite to the motion, you know about it. And also the driving force will act in downward direction. Why? Because it was moving in downward direction. And there is also component of weight, but that component of weight perpendicular to the inclined surface won't be required to solve this question. Okay, so which equation we should use? We should use P equals to FV. Why? Because it was moving at a constant speed. When something is moving at a constant speed, you can use this formula. P equals to force into velocity, but that force is driving force. That force is driving force. So what was the power of the engine? 31.5 kilowatt. We will convert it into watt. Now driving force. In downward direction, driving force and component of weight, and in opposite direction 1350 Newton. So as it was moving at a constant speed, the resultant force is 0. So driving force F plus mg sine theta equals to 1350. mg, mass was 1200, value of g is 10, value of sine theta 1 by 20, 1350. So from here we will get F. (1350) minus 600, that's 750. That will be the driving force. So from here we will get V. So that will be 31500 divided by 750. 42. So the corresponding velocity will be 42 meter per second, and that's a correct answer. So I hope you have understood, but this is a pretty much easy question. Generally the question of work, energy, power, sometimes you will get easy questions. Sometimes you will get difficult questions like pulley or inclined surface, or even momentum that will be incorporated in the question, which will make the question a little bit difficult. We will also solve those questions. This particular question is taken from specimen paper 2020. That syllabus is applicable for 2023, 24, and 25 session. And that was question paper 4, question number 3. This question is actually a combination of momentum and work energy power. A little bit of momentum and a little bit of work energy power content. So let's go through the questions first. 3 small smooth spheres A, B, and C of equal radii of masses 4 kg, 2 kg, and 3 kg respectively lie in that order in a straight line on a smooth horizontal plane. So no friction. Smooth horizontal plane, no friction. Initially, B and C are at rest and A is moving towards B with a speed of 6 meters per second. So at first, let's draw a diagram to understand what is happening here. Like 3 different spheres, A, B, and C. So B and C are stationary. Both of them are stationary. A was moving with a speed of 6 meters per second towards B. B. And at first, after the collision with B, sphere A continues to move in the same direction with speed 2 meters per second. Find the speed of B after this collision. So at first, A is colliding with B, and after that collision, A was moving with a speed of 2 meters per second. And what should be the speed of B? That is what we need to find out for A. Okay, so we will just simply apply law of conservation of momentum. A and B is stationary. So what is the law of conservation of momentum? MAUA plus MBUB MAVA plus MBVB. You can directly write down the values. All right. I'm writing down in details so that you can easily understand, but in exam paper you can directly put down here the values and find out the unknown. You don't have to write down in that detail, or you don't have to also draw the diagram. That's not necessary. I'm doing it for better understanding of students. Okay, so mass of A 4 kg, its initial velocity 6 meters per second. B was stationary, so zero velocity, that means zero momentum. Zero velocity, zero momentum. After collision, mass of A is 4, and A was moving in the same direction with a speed of 2 meters per second. Mass of B is 2 kg, and velocity of V, the velocity of B, we don't know about it, we need to find it out. So it's a very simple calculation. VB equals to 8 meters per second. Okay, so now we have got the velocity of B, that is 8 meters per second. So after collision with A and B, B was moving with a speed of 8 meters per second. Now, C was initially stationary. After the collision with A, B is moving with the speed of 8 meters per second. So B is eventually going to strike sphere C. Sphere B collides with C. In this collision, these two spheres coalesce to form an object D. That means they will combine. Coalesce means they will combine, and there will be a single object after the collision, and that particular object is termed as D. Now the question is, what will be the speed of that combined object? D. Okay, so let's see how to solve it. So for B and C, after collision, there will be a single object D. So again, law of conservation of momentum. Mass of B 2 kg. After collision with A, B was moving with the speed of 8 meter per second that we have found out in A. So that's 8. C was stationary, so the momentum is 0. And D is actually the combined object of B and C. So we need to add mass of B and mass of C, 2 plus 3. So the speed of that combined object D will be 16 by 5. 3.2 meter per second. Okay, so that's B. Let's move on to question C. In B, show that total loss of kinetic energy in this system due to the two collisions is 38.4. So simple, we will consider the initial kinetic energies. So initial kinetic energy. Just A was moving, mass of A 4 kg, speed of A was 6 meter per second. 72 joules. Now, after collision between A and B, A was moving with a speed of 2 meter per second. So after first collision, A was moving at a speed of, so kinetic energies after, so final kinetic energies. In case of final kinetic energies, so for final kinetic energies, you need to consider the kinetic energy of A, because after collision the speed of A is reduced. It was reduced from 6 to 2 meter per second. So half mass is 4, speed was 2. Combining mass of D, that means combining mass of B and C, 2 plus 3, and their combining speed 3.2 square. .6. So loss of kinetic energies, initial kinetic energy 72, final kinetic energy 33.6. That is 38.4 Joule. So that will be the final answer. Just for confirmation, 38.4 joules. Okay, fine. So let me repeat question C. So what's happening here? A, B, and C. So after the collision between A and B, A was moving with a reduced speed. So for finding out the final kinetic energies, you need to consider the final kinetic energy or final speed of A after collision with B, and also you need to consider the kinetic energy of the combined object D, which we have got after the collision between B and C. So in total, you are getting final kinetic energies after the two collisions, and also you have got initial kinetic energies, and in that case you have just considered the kinetic energies of A, because B and C was initially stationary, then you are subtracting the two energies to find out the loss of kinetic energy. So I hope you have understood. Hello dear students, this particular question is taken from specimen paper 2020. Mechanics paper 4, question number 7. The syllabus for 2023 to 25, mechanics, Cambridge AS level or A2 level. Two particles A and B of masses 0.8 kg and 0.2 kg respectively are connected by a light inextensible string. Particle A is placed on a horizontal surface. The string passes over a small smooth pulley. B fixed at the edge of the surface and B hangs freely. Horizontal section of the string AP is of length 2.5 meter. The particles are released from rest with both sections of the string taut. That means A and B, the string is under tension. We need to find out in the first question that if you consider the surface as smooth surface, find the time taken for A to reach the pulley. So how much time A will take to reach to the pulley at pulley P? Okay. So to find it out, we need to find out the time. So we need to find out the value of acceleration because the whole system is going to accelerate. The mass of A is 0.8 kg and the mass of B is 0.2 kg. 0.2 kg. Now, as the surface is smooth, so the surface is not providing any friction to A. And without any friction, if you keep any mass here, it's going to create some motion. It's going to accelerate the whole system, right? So B will fall downward direction and A will move in right direction. So we need to find out how much time A will take to reach to the pulley. So how we will do it? We will apply Newton's second law. So first, we all know that tension always acts inward. So here tension will act and here tension will act, and the magnitude of the tension in both part of the string will be same. Now for B, if we resolve the force for B, the mass of B is 0.2 kg, so the weight will be 0.2 g. So for B, as the system is moving in downward direction, so B will accelerate in downward direction. So if we apply Newton's second law, 0.2 g minus tension equals to mass into acceleration. Mass of B is 0.2. So that's equation 1. And for A is going to move in right direction. And as there is no friction, there is no resistive force, so tension T will produce the acceleration for A. So T equals to mass into acceleration. Mass of A is 0.8. Now we need to solve these two equations simultaneously. Then we will have the value of A, right? So value of A is 2 meter per second square. For finding out the time, we have the distance. So we can apply the formula. We can use the equation of motion S equals to ut plus half a t square. How much distance it needs to cover? 2.5 meter, right? And initially the system was stationary, object A was stationary. So this part is going to be 0. Acceleration we have found out as 2. So from here we will get the value of t. So value of t will be root over 2.5. Always remember the answer you need to find out in 3 significant figure, right? So root over 2.5. 1.58. So it will reach the pulley in 1.58 seconds. Okay, so that's very simple. Now let's move on to question B. The surface is rough and at the speed of A immediately before it reaches the pool is V meter per second. The work done against friction as A moves from rest to the pool is 2 joule. Use an energy method to find V. So at first we need to make an equation related to energy conversion of energies. Now if you look at the system will move in downward direction definitely. So what will happen, both of B and A, they are above the ground, so they have some gravitational potential energies, but we will only consider the loss of gravitational potential energies of B but not A. Why? Because the position of A is being changed in horizontal direction. So the position in horizontal, if you consider vertical direction, the position of A in this direction is same, so it's not actually losing any quantity of energy. It's not losing any quantity of energy in terms of gravitational potential energy, right? So B is only losing gravitational potential energy, and that loss of gravitational potential energy is converted to kinetic energy of both B and A, because the system will move at a constant rate, right? So the loss of gravitational potential energies of B will be converted to the kinetic energies of A or B, A and B, or you can say kinetic energy of the whole system, and also to overcome the frictional force. So you can write an equation like that: loss of gravitational potential energies of B. That energy will be converted to the kinetic energy of the system. And speed of both the object will be same, v. The moment A reaches to P with velocity v, B will also descend the same distance 2.5 meter and will have the same speed as v. So they will have a combined speed of v. And also some part of the loss of gravitational potential energies of B will be converted to heat energy or energy to overcome friction, that is 2. Now let's put the values. Mass of B is 0.2, H is 2.5 meter. So it's going to be 5 0.5 is square. Three divided by 0.5 square rooted 2.45 meter per second. So the velocity will be 2.45 meter per second.